everyone, today's lecture is about population and sample. As in the last semester you have studied about the basic terminologies of stats and some basic terms about population, sample and different types of sampling. So in this semester or in this course, we still study about sampling, but the concept is little bit different. So first of all, I am starting from the very first topic, that is population and sample. So the concept now is a high level concept and we will do some practical on it as well. So first of all, start from the video. So I am running the video that will introduce you about the concept of population and sample, and the sampling in this lecture is about two types: sampling with replacements or sampling without replacement. We have just performed the practical of dice game in the class, the actual physical practical, and we have also performed the practical of balls and drawer in the class. So let me start the video, and you will get the concept if you have listened to the my practical carefully. Start.
For example, all registered voters in Thailand, or all Hong Kong citizens who play golf at least once past year, or all neurons from your brain. Since we cannot get information for every individual of these populations, we have taken sample, which is a part of target population. Sample is a small group of population. It is a representative of the population. Hence, it has to be randomly selected. This process is called random sampling. There are two kinds of sampling, called sampling without replacement or with replacement. Depending on whether you put the select individuals back into population before you select the next one. In the sampling without replacement, an individual is randomly selected from the population. The next individual will be selected without putting the previous individual back. Every individual is selected from a different pool. If the population size is very large, this method is better because it can generate a random sample with different individuals. There is another kind of sampling method, sampling with replacement. A randomly selected individual will be put back before the next individual being selected. Hence, it is possible that the same individual can be selected more than once. When the population is small, this method can make sure that everyone in the population has the same chance being selected. In this example, we first create a blank data frame, and we create a new column in this data frame. Name the column as population. Then I run this Python code to perform sampling from the population by drawing 5 individuals randomly, without replacement, and store them as a sample without replacement. In Pandas, we can use method sample to get the samples. Here, the keyword replace equal to false means the sampling is a sampling without replacement. We can define replace equal true to perform sampling with replacement. Here are the results of 2 samples. You can see that for sampling without replacement, which is on the left-hand side, there are no duplicates individuals found. As we can see, there are no duplicate index numbers either. However, on the right-hand side, which is sampling with replacement, it is possible to see the same individual is drawn for multiple times. Besides population and sample, there is another pair of concepts, parameter and statistics, of which are very important in characterizing population and sample. Parameter is a characteristic or summary number of population. Statistic is a characteristic or summary number of sample. For example, mean, variance, standard deviation of population are characteristics of population. Once target population is fixed, these summary numbers will not change. Sample also has mean, variance, and standard deviation, but their values changes in different samples, even if they are drawn from the same population. Let's print out the parameters of population, which we have just created. We can calculate mean, variance, and standard deviation using data frame methods .mean, .var, .std. The mathematical formulas for mean and variance are given. In calculating VAR and STD, we set the keyword DDOF as 0, which means the denominator of population variance is n, which is the number of population. Dot shift, as described in previous module, alters the size of data frame in rows and columns. We use dot shift 0 to display only the number of rows. Also, these methods can be applied to compute statistics of samples. First, let us give a sample with size 10 from population using replacement. The sample and the sample variance, standard deviation, are printed out. Notice that when we compute the sample variance and STD, we need DDOF equal to 1. It means the denominator of the sample variance has to be n-1 instead of n, which is the sample size. To understand why the denominator of the sample variance is n-1, let us generate 500 samples, each sample with size equal to 50. We calculate the sample variance for each sample using n and n-1 as denominators. You'll find that the real population variance is 571.8. As you can see, the average of sample variances using n-1 is closer to population variance than using n. The average of sample variance using n as denominator is always smaller than population variance, with some mathematical reasons. n-1 in fact is called degrees of freedom for sample variance. There is another explanation why sample variance is divided by n-1, which is the degrees of freedom. Degrees of freedom is a number of values used in calculation that are free to vary. When we use the sample mean to compute the sample variance, we will lose 1 degree of freedom. For example, sample size equal to 3, sample mean equal to 100 is used in computing sample variance. We can choose 2 individuals independently, for example, 90 and 80 in the table. But the third is not free to vary because of constraint of sample mean. The only choice for the third number is 130. When we compute the variance, using degrees of freedom is better than using sample size, in the sense that the average of estimator will be equal to population variance, which is called unbiased estimator. In the next video, we will talk about distribution of sample statistics.
So this is the explanation about sample and sample with replacement. So we have also uploaded the practical of population and sample on my GitHub. So there are basic libraries. You can see I have made a data frame name as population. Now I am taking 2 samples from this, and you can see here it is written replace is equals to true, means none of the values would be repeated. So it is sample with replacement, and in the without replacement, replace is equals to false. in this there is a chance of values without replacement. Basically, with replacement means that you can repeat the values, and without replacement means you cannot repeat the values. One which is selected cannot be selected more than one times. So the parameter and statistics. So here it is. Population means and population variance, and this is your for homework. You can calculate the population mean as seen in the video, and for calculating the population mean I am just telling you, you have to do a very simple work. You have to write data frame, because the data frame is read in the variable data, and you will write data population, and for calculating the mean you can write dot mean. Okay, so in the same way as you have seen, so you can calculate variance as well. Let me show you about it. So as you can see in the video, that we can find population mean and variance both. So I'm writing here dot var. Okay, and in this way you can calculate population mean and population variance, and you can get different results according to the selection of different samples, means the sample size is increased or decreased. So this is for your homework, and it is uploaded on the GitHub, and you can calculate it according to your choice. Okay, and you can also change the data set and got the basic idea that what is happening. The lab name is practical population and sample, and all the things about it has been explained in the video given to you. Okay, so you have to calculate the required parameters for the complete data, and then you have to calculate the parameters for the sample, and you have to see the difference, and you have to know what is DOF used in this practical, and what is the difference between using DOF is equals to 1 or DOF is equals to 0. So all things are written here, and you can see, and all the logics behind it has been explained. So it's for your homework time. Do your homework, send me an email and ask if there is any question. I recommend you to see the video again and again to get the better idea that what is population and what is sample, what are parameters, what are statistics, and what is the difference between the sample standard deviation and the sample mean. And finally, after calculating these difference, know what is the use of DDOF, degree of freedom, in selecting as 1 or 0. All the things are explained. Hope you got the better idea about it. Thank you.